Suppose you wish to compare two PCCs from the concatenated orderings ordinal analysis procedure. And more specifically, you want to know if those two PCCs, if the difference between them is readily explainable by physical chance, or in terms of Aristotelian language, you want to know if that difference can be readily explainable in terms of accidental causes. So to see how this can be done in the software, let's again turn to the affective realism data. And we have the positive, neutral, and negative images that have been rated. And what we want to do here is separate the analysis by eye dominant. So we want to see what we could get for the PCC for right eye dominant individuals and left eye dominant individuals. So we move that over to the separate by box. Now we can define the ordinal pattern. I'll expand this out just so we can see what's going on. And for notice the right eye dominant individuals, we expect the positive to be greater than the neutral, which is to be greater than the negative rating. So there's the ordinal pattern for the right eye dominant individuals. Now for the left eye dominant individuals, we're expecting the same ordinal pattern. So what we're hoping here is that the two PCCs will be high, and they'll be very similar in terms of their magnitude. So we can select OK. Now let's select the randomization test, and let's save the randomization results. You'll see why we need to do that here in just a few moments. I'll leave all the other default options selected, and we'll select OK to run the analysis. So it iterates through. And let's scroll to the top here. Here we get all the summaries of the options we chose and summaries for the orderings. And then we get the right eye dominant individuals. There are 20 of those individuals. Let's focus on this particular PCC. We could look at the other PCCs from the analysis in the same manner, but let's focus on this PCC, which is for the classifiable complete cases. So of the 20 individuals, 6 fit the expected ordinal pattern perfectly all the way across, and so that's 30%. So we have 30% for the right eye dominant individuals. Now let's scroll down, find the same PCC for the left eye dominant individuals. We have 25 of those individuals, 5 out of 25, as you can see here. So that's 20%. So the 20% is a little bit lower than the 30%. So we have 20% for left eye dominant, 30% for right eye dominant. Now, is that difference readily explainable by physical chance? So it's not something we really need to worry about in terms of an important theoretical difference between the right and left eye dominant individuals. So one way you can address that question is to examine the PCC indices that were generated from the randomization tests. So notice we have a number of new data sets that have been created from the analysis. Here's the first data set that was created, and we can see that we get the classifiable pairs of observations, the correct classifications, and here's the PCC for all the pairwise comparisons. Here's the classifiable complete cases, correctly classifiable complete cases, and then here's the PCC we want to focus on. It's the percent correct classified cases. So this is the PCC we want to focus on, and this is for the right eye dominant individuals, as you can see in the title here. Now we get the same type of output in this data set. This is for the left eye dominant individuals. So here is the PCC we want to focus on. So what we're going to do is we're going to copy these PCCs over into the right eye dominant data set. First, I'm going to label it or rename it. So I'm going to select the Define Orderings button. And here is the ordering we want to copy over. And I'm going to call it PCC, let's say complete or comp for complete, and we'll use L for left and select OK. So there I relabel it. Now I'm going to copy it over into the right eye dominant data set. So I'll select Edit and then Copy, Delete Orderings. There is the ordering we want to copy over. I'm going to paste it into this data set. Now you can see that's cut off here, the label is. You can expand this out and you can see the complete label. So there it is. So there is the ordinal randomization results, or are the ordinal randomization results for the right eye dominant. That's the data set we want to paste it into. Select OK. And go to that data set, or it took us there automatically. And so here you can see now I've got the PCC comp left pasted right next to, or concatenated right next to, the PCCs for the right eye dominant individuals. I can go ahead and just relabel this one as well, just to help me keep this clear. Particularly if I save this for later analysis. So there we have it. We can also put labels over here if you wish. You can label or add a description to remind yourself of what this ordering is all about. So I'll select OK here. So now what I want to do is look at the differences between these two PCCs. Now incidentally, you'll notice by default this went to a decimal precision of 0. That really doesn't matter, but if you want to set it to 2, I think they're all whole numbers is why that's happening there. There you can see. All right, so that's just incidental. Now what I want to do again is compare the two sets of PCCs and see how often we get a magnitude of 10 or greater. So what we need to do then is compute a difference score. So I'll select compute and then compute a new ordering. And there is the right, they were 30. And so we'll go ahead and take the right PCCs and we'll subtract, we'll toggle that to the subtraction sign there, and then we'll move over the left. So PCC for the right, PCC for the left. These are randomized PCCs. And so now we can call this PCC diff. And we can even put a little additional annotation there to let us remind us what we've done here, right minus left, select OK. And there we get the differences between the PCCs. Now what we need to do is examine the distribution. So I'll select the Define Orderings button and go ahead and expand that out. And there we have it. And I'll select the distribution. So you can see something of a normal distribution there for the differences. But we have a very specific question here. We want to know how many of these PCCs are 10 or greater. So how likely are you to find a PCC of at least 10? So what I'm doing here is I typed in a colon, and now I'm going to select and go all the way down to the highest PCC, which is 41, and hit the delete key. So what I've created here now is a range, 10 to 41. I can label it, if I can get the cursor in the right spot. So 10.00, and I can update this, and there we see it. So we have 198 out of the 1,000 randomized PCCs, or the differences between them. 198 of those were 10 or greater. So that is essentially a chance value. And here it's about 20%, 0.20, so not very impressive. Meaning that you can just randomly shuffle the data and compute differences and find 10% or higher fairly often, at least 20%. Now you might also want to know the values of -10 or less. So we can again make that same kind of edit to how the data are viewed here, or visible. So I'm just going to block and delete, and then put a colon there. So now I have -34 to -10. I'll go ahead and label it here and update it so we can just see the labels. So there you have it, -34 to -10, 10 to 41. So a difference of at least 10 points one way or the other. Now you see we have 0.185 plus 0.198, whatever that total is, about 40%. That's how often or how frequent you can find a difference of, again, at least 10% in the PCCs one way or the other. So this might be the more appropriate question for you with regard to how you want to try to rule out physical chance. It's entirely up to you whether you want to run this almost as in the traditional parlance as a one-tailed test or a two-tailed test. But nonetheless, that's how you do it. And for these data, that 10% difference, looks like you can safely chalk that up to just physical chance.